This video is sponsored by Brilliant. GitHub Actions does not spark joy. I know because I've spent hundreds of hours fighting with it over dozens of projects. I never chose to suffer GitHub Actions. Past employers or other open source projects made that choice for me. But why did they? And why does it feel so bad to use it? And if it does, why are we still using it? It wasn't always that way. Although computers were originally employed in service of futile pursuits like waging war or landing on the moon, the advent of the personal computer unveiled entirely new use cases, such as playing strip poker with a heavily pixelated Samantha fox. For the first couple decades, there was a thin line between computer professionals and hobbyists. Those who assembled their own computers had intimate knowledge of the hardware and learned machine code from books. Over time, computers grew more powerful and we had to develop layers of abstraction. In 1987, the first version of GCC is released. It's the first C compiler that is both good and free. Its release happens in the middle of a wave of IBM PC clones. Soon, everyone will have a computer at home. And it won't be a toy, it'll run the same applications you have at the office. An abundance of semi-affordable, somewhat standard hardware, a decent toolchain, and a manifesto is enough to kickstart a worldwide effort to write a metric ton of free software. But GitHub is another 20 years out, so how did thousands of people collaborate on this body of software? It was very human. Someone would be in charge of maintaining a project, which means they owned the canonical copy of the source code and decided what changes to include or not to include of the patch files they received by email. This is how Linux kernel development still works today. I know because I recently noticed that the memory hot plugin documentation mentioned a fist phase. Turns out it's just a first phase. This approach, however hostile to new contributors, does scale. You just need a hierarchy of maintainers and a version control system that can actually keep up with the size of the project. For the first decade of Linux development, that system was named Linus Torvalds. Although several developers maintain CVS trees, Linus refused to use it. On a technical basis, it's too slow, it does not scale, and on a political basis. He believed that CVS, quote, allowed automatic acceptance of patches and positively encouraged people to dump their patches on other people and not act as real maintainers. This makes it seem like Linus believes that a higher barrier to entry drives up the quality of software, which is odd because in The Cathedral and the Bazaar by Eric S. Raymond, the Bazaar is Linux. And the explosion of the open source movement, thanks in part to forges like GitHub, which significantly lowered the barrier to entry, can be traced back directly to Linus's work on Git, which he only made because after years of using a proprietary solution for free, someone violated the license and they had to stop using it. Linus didn't want to make Git. Back in 2002, he didn't give a fuck about ideology. The free software people were saying shit like, the spirit of the BitKeeper license is the spirit of the whip hand, which, fair, but Linus doesn't care, he just wants something that works. He tells the free software people, and I quote, I would suggest that if you are silently seething about the fact that a commercial product can do something better than a free one, how about doing something about it? If Trigil hadn't tried to make a piece of BitKeeper compatible software, we wouldn't have Git, and open source wouldn't have exploded the way that it did. GitHub didn't invent patches. The Diff command originated in the 70s, and the patch command was made by Larry Wall, the Perl guy, in '84. GitHub didn't invent issue tracking. We had Bugzilla and later Track before Git was even a thing. GitHub didn't even invent forges. I'm old enough to not miss SourceForge, Savannah, or Launchpad. However, GitHub is among the first Git-centric forges, along with Gitorious, Bitbucket, and later GitLab. Git alone is a significant upgrade over CVS and Subversion. But it doesn't stop there. GitHub puts code right in front of your face. GitHub acknowledges the social nature of software development. It lets you follow people. It lets you fork repositories to your own personal namespace. And GitHub invents pull requests, a thing you can do now because Git is decentralized, so everyone has their own repository and you can pull commits from any origin. GitHub wins because it's good. People like using it. Sure, SourceForge starts bundling adware, and Bitbucket sells to Atlassian, but they're not just absorbing refugees from other forges, they're leading the way in designing what collaboration will look like for years to come. And then around 2018, they start looking at continuous integration. What's continuous integration? Well, not every project has a Linus to act as gatekeeper, but you still want to make sure that despite multiple contributors and frequent change in requirements, the software keeps working. We figured that out back in 2001 at a ski lodge when 17 guys came together and decided to unite all their lean software development methodologies under the Agile umbrella. Methodologies like feature-driven development, Scrum, and extreme programming, all of which are translating to the software industry lessons that Toyota had learned making cars in the 50s.
Japan is a small island nation that just lost the war. They don't have the cash or real estate to get into manufacturing the way other countries did, by having big factories with lots of inventory. They can, however, make small factories that produce exactly what the customer needs, just in time. Also, encouraging humans to identify waste they can eliminate from the process and stopping production if they notice anything that can get in the way of quality. This is later dubbed lean manufacturing by some American dude just as the software people start taking notice. A 1989 paper describes Infuse, an experimental setup that aims to, quote, address the special problems of developing and maintaining large-scale software projects. Unit tests and integration tests already exist. Infuse makes them a requirement for changes to be merged. Version control and the test harness have to work together as part of the same system to preserve quality. The term continuous integration is coined a few years later by Grady Booch, the UML guy, and today CI mostly means having GitHub run a bunch of tests before you merge a PR,
which is a fairly recent development. For its first decade, GitHub has tried really hard not to build a CI system. They built integrations so that other systems like Jenkins or Travis could pull code from GitHub when a change was made and report back on the status of the build, which is smart. Doing CI is hard, it's expensive, it requires lots of compute, which bad actors try to steal to mine cryptocurrency. Building a continuous integration system would take years, and they couldn't afford giving it away to all open source projects anyway. Did you just bite me? Don't bite. But you know who does have a lot of compute and a pre-existing CI system ready to rebrand? It's Microsoft. They buy GitHub for $7.5 billion with a B dollar dues. What are they buying? What is any big company buying, really? They're buying love, they're buying street cred, they're buying the platform 31 million developers call home, and they're preparing to switch gears. Up until then, GitHub had been, pardon the truism, the hub, the center of an ecosystem of partners connected through APIs and webhooks. When they announced GitHub Actions, the version that used the HashiCorp configuration language instead of YAML, the one with the graphic pipeline editor, the one where steps run in parallel, that one. When they announced that, they're not taking over the CI business. They have partners like Pulumi, HashiCorp, Netlify, demonstrates the actions or reusable bits of code that they wrote to integrate with GitHub. What they're announcing is a general purpose automation system that can perform actions in response to certain GitHub events. This is a shift. You no longer have to run your own server. For the first time, GitHub is willing to grab anyone's code from repositories and run it on their infrastructure. In 2019, they announced GitHub Actions, the second, the one you know and love, which is closer to a traditional CI system. It supports Windows and Mac OS, you can use artifacts to pass data between jobs, you have live logs. They seem to have built an awful lot of functionality in a very short amount of time. What happened? They forked Azure pipelines is what happened. They say so in their own documentation. And when I started reading the code for their official actions as research for this video, I didn't know that. Now that I do, things make a lot more sense. And it's time for a completely unsolicited and frankly quite rude review of the GitHub Actions code. But first, a word from our sponsor. This video is sponsored by Brilliant.org, the best way to learn math and computer science interactively. I know what you're thinking. Amos. What's wrong with going on a Wikipedia bender, reading all the pages you can find until you fall asleep on your keyboard and wake up to notes that look like the crazed ravens of a fallen king cursed with badness? Well, nothing. But sometimes I like things to be a little more curated, and I'm always pleasantly surprised with the quality of courses on Brilliant.org. Like this course, it starts off with general education about AI-generated content, which you could use to teach your loved ones about this information. For example, I'm just spitballing here. But it doesn't stop there. It teaches you about engrams, how models are trained, pre-processing, tokenization. I felt like it was a really good introduction to all those concepts underlying large language models, and that if I want to go deeper, now I know what to look for. There's over 100 courses on Brilliant, and if that sounds intimidating, don't worry, it'll have you answer a few questions and create a personalized learning path that fits your goals, your interests, and how long you want to spend learning every day. Go to brilliant.org/fastedandlime to get a 30-day free trial of everything Brilliant has to offer. The first 200 of you to subscribe will get 20% off. That's with brilliant.org/fastedandlime. You can find that link in the description. Now, if I had to review this code seriously, I would start with big picture concerns first. Why are we building this? Are we sure that we're building the right thing? And keep nitpicks for later. But for narrative purposes, let's do the exact opposite. This function is bad. A function named create_gzip file on disk should create a gzip file on disk. It should not use knowledge that the only caller of that function will use the uncompressed version of the file if it returns a large enough number. Nothing about the function's name or signature suggests that it's doing any filtering, or that it's able to return values upwards of 9 quadrillion bytes, thereby making it more likely that a refactor of the caller will make the entire thing collapse like a house of cards. Also, if you truly wanted this function to behave like a function named create_gzip file on disk if I feel like it, you should have it return an enum or something. This isn't C, you don't need to create your own niches so that the return value fits in a single register. This function is bad too. It's used for the initial JSON post and for every binary chunk we upload. Instead of having one function for common headers and 2 functions for the endpoints, you have a single function with 6 optional arguments, which means there's 64 different code paths. If we're sending the API version in the accept header, why are we also sending it as a query parameter? And why is that version 6.0-preview in a stable release of your package? Are the backend folks supposed to maintain that version forever? I'm sure it's just a temporary, never mind, it's been there for 4 years. Why are we sending the uncompressed length as a proprietary header when the gzip format already has an 8-byte trailer with that information along with the CRC32 checksum? Speaking of checksums, why are we sending the MD5 and CRC64 checksums for every chunk we upload? How are we even doing CRC64? Node.js doesn't... Oh no. Oh, look, I may not be the greatest fan of the Go language. But you know what Go has that JavaScript doesn't? 64-bit integers! The original Go implementation grubs about 1 gigabyte per second. I found a Rust/SymD implementation that can serve 2.6 gigabytes per second. Do you want to know how fast the TypeScript port used in GitHub Actions is? I'll give you a hint. It's not gigabytes. On my machine, their code does 30 megabytes a second. They successfully made an upload CPU bound, and it's not even the compression. I just... But there's a reason they don't use, say, the Node CRC package, which is backed by a Rust implementation. It's because they can't. The one thing that didn't change between the 2018 GitHub Actions beta and the Azure Pipelines rewrite is that it's in deep denial about being a package manager. It doesn't want to. No. No package registry, no semantic versioning, no log files, no yanking, no two-factor authentication, no transparency logs, only Git. And here we enter the battleground of GitHub product versus GitHub security. GitHub product's idea of semantic versioning is to force push tags named v1 so users get feature and security updates. GitHub security says, if you do that, you're begging for a software supply chain attack. Please only refer to full Git hashes. It's the only way to pin dependencies in this system. What about transitive dependencies, the dependencies of your dependencies, your grand dependencies in a way? There aren't any, because GitHub Actions doesn't want to be a package manager, so it doesn't install Actions dependencies. Instead, you have to paste together megabytes of JavaScript code from your node modules directory using a tool like NCC and push the resulting crime against humanity to your Git repository. And that's why they can't use native node add-ons. Those have a post-install step that downloads the correct binary for your platform. To get them to work, you'd have to commit binaries for all possible platforms to your Git repository, which... Okay, if you're doing that, don't tell me in the comments. I don't need to know. I don't want to know. But don't worry, all the code we reviewed so far is on its way out, because you see, there's problems with it. I mean, there's more problems with it. The files are uploaded in parallel, but they're divided in chunks which are uploaded sequentially. So if you have one big file, it's slow because each chunk is a separate HTTP request. You spend a bunch of time waiting for the backend to acknowledge the chunk you just sent. If instead you have lots of small files, then it's really fast. So fast, in fact, that you may get rate limited and not be able to upload the artifact at all. Anyway, to fix all those problems, they've been working on a new version for quite some time now. The JSON call is being replaced by protobuf for reasons that escape me, and instead of uploading each file separately, it's compressing and uploading all the files as a single zip archive in a streaming fashion. But how do you think they speak protobuf or create a zip archive? That's right! It's the square hole! Stop implementing binary protocols in JavaScript, you heathens! So that's one approach, just to do everything in JavaScript. The cache action takes another approach, just use whatever is installed in the system. It has 300 lines of code dedicated to finding GNU tar or BSD tar, determining whether it supports the C standard, and cooking up the appropriate argument list before shelling out. This is a shell script. You're writing a shell script in JavaScript, which is arguably a step up from writing a shell script in Bash. But you have Docker actions. You can ship containers instead of Node.js codebases. Why do you not want to use Docker actions? Is it because it adds so much friction to the development cycle? Your people eventually walk into the forest, never to be seen again? Yeah? Yeah, that makes sense. I actually liked the original GitHub Actions. The promise of GitHub Actions was that you could build your own system out of composable units of code. Its imperative nature, almost everything is code, made it hard to statically analyze, but it was, at least in theory, infinitely extensible. Traditional CI systems check out code for you. GitHub has a checkout action you need to manually invoke. In theory, checkout being an action is great, because it means anyone could have written it. It just runs git clone, right? What could possibly go wrong? Except they couldn't have written it, because one, where does git come from? Having to download it every time would suck. GitHub just added it to all their VM images. And two, where do the credentials to clone private repositories come from? Only GitHub is able to automatically generate a short-lived API token just for that repository with variable geometry permissions. Having the workflow definition inside the repository is all fun and games until you realize that anyone can open a PR and run their workflow in the context of your repository. Sure, you can require approvals before running workflows from strangers. That's not going to save you. What is going to save you is GitHub turning that token read-only and hiding secrets from workflows from pull requests from a fork. Something only the platform owner can do, and which also limits you to only using GitHub resources in CI for pull requests from a fork. You can't cache things to S3 if you don't have the secret for AWS credentials. If you need write access or secrets, you'd have to do it separately on workflow run events using artifacts to pass data between the first and the second job. This works because the definition of workflow run jobs is read from the default branch of the original repository, so attackers can't mess with it. Also, even though this contraption is the only safe way to do this, you have to use a third-party action to download the artifacts, because it's from a different workflow, a use case the official action doesn't support. So okay, this is more complicated than it seems. I guess not all functionality can be added to GitHub Actions by third parties. Sometimes it works out great. Action Teammate by Max Schmidt lets you connect to a running job over SSH, saving you multiple rounds of CI golfing. The community has poured a tremendous amount of work into Act, a local runner for GitHub workflows. But once again, we run into limitations caused by GitHub Actions' identity crisis. Let's have a bit of fun. Can you guess how large the GitHub Actions Ubuntu VM image is at the time of this video? Is it A, 500 megabytes, B, 1.4 gigabytes, C, 3 gigabytes, or D, 7.1 gigabytes? Wrong. You're wrong. It's 51.2 gigabytes. It would take half an hour to hash with their CRC64 implementation. I'm sorry. I'm trying to stop. So Act recommends using smaller images, and then your actions don't work because you're missing something they need. Also, those VM images update regularly. If you're on Ubuntu latest, why are you hitting yourself? But even if you're on, say, Ubuntu 2004, your workflow can break in your sleep. But that's what Docker is for. At least we can run jobs in containers so that we can pin all the exact dependencies we need. But if you use private registries, the runner itself needs to have credentials to pull that image. You can't just make an action your way out of this one because it happens before any of the steps run. But wait, how do Docker action steps even work if the entire job's already in a container? Do they do Docker in Docker, or didn't, as it used to be called? No, they do not. They run them as a sibling container with a bind mount of the working directory, which I'm assuming is a fine solution until it isn't, because things get weird, probably? But now I'm thinking, if you have a job run in a container that doesn't have Git, say on Alpine Linux, does the checkout action even work? Aha! It does. Kinda. It uses the REST API to download and extract a tarball. I hope you see the tiny little log line before you spend hours wondering why some other action broke because it expected a Git repository on disk. But wait, checkout is a Node.js action. This container image does not have Node.js. How did they make that happen? Do you think they A, run the action outside the container where Node.js is installed, B, run the action in a sibling container with a bind mount, just like they do Docker actions, or C, use the distribution's package manager to install Node.js if needed? And the answer is D! They pipe cat into grep to figure out if your container is Alpine or not Alpine, the two genders, and decide which of the node binaries they mounted into the container to execute. So they won't run npm install for actions, but they will ship their own node binaries. If you need an apt package that's not in their 52 gigabyte image, you'll need to install it on every run. But if you download executables with curl, you can put them in the toolcat, which is persistent across jobs. Do you see what I mean when I say GitHub Actions is in denial about being a package manager? So why does GitHub Actions feel bad? For a while, I thought I was mad at them for pretending everything's simpler than it actually is, just like Go does, but I don't think that's true. I think they're just as confused as we are about the towering inferno they built. They're not even sure what their own features are named. The docs mention check suites and check runs, but the web UI calls check suites runs and check runs jobs. According to the docs, you should only create check runs from GitHub apps, but actions can request write access to checks and you can hit the API endpoint just fine. Problem is, GitHub has no way of knowing what check suite those runs should belong to, so it just picks one at random. And it's been that way for 4 years. So I don't think the GitHub folks are pulling a fast one on us. They suffer the situation as much as we do, except they're on the receiving end of a mountain of tickets they can't fix because it's too late now. At Usenix 2023, a group of researchers presented Argus, a framework for stage static taint analysis of GitHub workflows and actions. They found 3,643 high-impact vulnerabilities, which means all an attacker has to do is open an issue or a pull request with a carefully crafted title or email address or branch or any other thing they control, and the GitHub workflow will execute that as if it's Bash or JavaScript. Though it doesn't support Docker actions for obvious reasons, Argus is amazing work, especially considering how convoluted GitHub Actions can get. But here's a radical thought experiment. What if GitHub removed the footgun altogether? GitHub security already recommends you pass untrusted user input through environment variables to avoid accidentally executing it. Why not simply refuse to interpolate inline scripts? Just don't replace the brackets with anything. Why not do that? Because it would break everyone's workflows. They would have to introduce deprecation warnings gradually over months and then finally back off when they've got a riot on their hands and corporate customers are threatening to move to GitLab. It's too late to fix it, just like it's too late to figure out a way to solve dependencies that doesn't involve a 50 plus gigabyte image. You can't take this away now. GitHub Actions is a triumph of capitalism. It could not have happened at a better time. It was able to sweep up everyone left out to dry by Travis CI getting acquired into oblivion, and Microsoft was the ideal partner to make that happen. They did a good game of business, and they won, and I respect that to some extent. But I'm also sad that the original vision for GitHub Actions was never realized fully, and probably never will. I'm sad that GitHub has reached a level of market penetration that makes it almost impossible to compete with. It doesn't matter if something better exists at this point. GitHub Actions is good enough, and it's right there, and we already have a contract with them, so stop asking! My only consolation is that As far as monopolies go, it could be worse. We have pretty decent self-hosted clones of GitHub. Some can even use Act to run GitHub Actions workflows. I routinely use NeoVim just in case I need to give up VS Code one day. Sometimes I disable Copilot just to feel something. Now, on the infrastructure side, we are 100% fucked. Dozens of package managers rely on GitHub releases for downloads. Homebrew uses GitHub's package registry. The Rust project leans heavily on GitHub Actions and AWS credits. There is no divorcing yourself from that reality. There is no ethical software development under capitalism. Ideological purists who'd like to pretend otherwise are hypocrites who send younger masses to misery and burnout without even a second thought. Fuck him. Get paid. Feed your family. And if you can contribute to the commons while doing so, that's a privilege. Use it wisely. Thanks for watching, and until next time, take care. Bye.
I'm a patient man. There's one thing I've been waiting for my whole goddamn life. My eyes are aching, man, but I can't blink just in case it falls when I close my eyes. I know I should let go, but there's a part of me that still holds. It can do it, but every time it gets close, double bursts off of both walls. I'm still waiting for the DD logo to hit the corner of my TV. The little baby's driving me loco. Who knew a graphic could be tricky? It's just me. My eyeballs all no crispy to the touch.
I can touch my own eyeballs, is that normal?
I'm waiting for the DD logo.